Task number 4, ICMP, Troubleshooting Networks. Internet Control Message Protocol is the acronym ICMP. Is mainly used for network diagnostics and error reporting. Two popular commands rely on ICMP, and they are instrumental in network troubleshooting and network security. These commands are ping and traceroute. Ping, this command uses ICMP to test connectivity to a target system and measures the round trip time, RTT. In other words, it can be used to learn that the target is alive and that its replies can reach our system. And traceroute, this command is called traceroute on Linux and Unix-like systems and traceRT on MS Windows systems. It uses ICMP to discover the route from your host to the target. Ping. You may have never played ping pong table tennis before. However, thanks to ICMP, you can now play it with the computer. The ping command sends an ICMP echo request, ICMP type 8. The screenshot below shows the ICMP message within the IP packet. So again, we captured with Wireshark an IP packet. And in here we can see the type 8 echo ICMP request. Ping request, right? And then you can see more information. Also, basically encoded data over here. The computer on the receiving end responds with an ICMP echo reply, ICMP type 0, as you can see over here. Pretty easy. From the source and from to the destination, from the source to the destination on the IP version 4. Many things might prevent us from getting a reply. In addition to the possibility of the target system being offline or shut down, a firewall along the path might block the necessary packets from ping to work. In the example below, we use -C4 to tell the ping command to stop after sending 4 packets. I believe that this C is from count. Let's see. Manual of ping, and we are checking. -C is from count. Stop after sending count echo request packets. So if we say ping C4 as an example that we have, and then we go for, say, google.com 1, 2, 4. Bam, 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 bam. We expand this, you can easily see them. Oh, actually, you can see them in the same manner. But 4 packets transmitted, 4 received, 0 packet loss, and the time in milliseconds. That's pretty much it displayed. And here we can see the same thing, but it's the ping on this IP, which is, let's see if we can access that first of all. No. Maybe the IP of some vulnerable machine. Anyway. The output shows no packet loss. Moreover, it calculates the minimum, average, maximum, and standard deviation, MDEV, of the round trip time, RTT, as you can see over here and as you saw in our example. Traceroute. How can we make every route between our system and a target system reveal itself? The Internet Protocol has a field called time to leave, TTL, that indicates the maximum number of routes a packet can travel through before it is dropped. The router decrements the packet's time to leave by 1 before it sends it across. When the TTL reaches 0, the router drops the packet and sends an ICMP time exceeded message, ICMP type 11. In this context, time is measured in the number of routers, not seconds. The terminal output below shows the result of running traceroute to discover the routers between our system and example.com. Some routers don't respond. In other words, they drop the packet without sending any ICMP message. Routers that belong to our ICSP, Internet Service Provider, might respond, revealing their private IP address. Moreover, some routers respond and show their public IP address, and this would let us look up their domain name and discover their graphical location. Finally, there is always a possibility that an ICMP time exceeded message gets blocked and never reaches us. Here we see this traceroute command used on example.com, and then you can see all the information that we read about over here. If you want to expand on this, just use traceroute on a website and you can see all the information that you want. The traverse route might change as we rerun the command. Answer the questions below. Using the example images above, how many bytes were sent in the echo ping request? 40, I believe. If we watch over here, 40 bytes of data. Which IP header field does the traceroute command require to become 0? This time to live. Indicates the maximum number of routers a packet can travel through before it drops 0.